Is Eshan Rao. I'm a PhD student from Indian Institute of Technology, Tirupati. This is the second live session from my side for data analytics with Python. This sessions usually it's happening parallelly and done by other TAs as well, where we aim to give you something little different at the same time related to whatever is happening in the NPTEL course. So apart from me, there are 2 or 3 other live sessions are happening mostly on Tuesdays, around from 6 to 9 kind of thing. I am having this from 6 to 8. All the sessions are recorded, and we are making a YouTube video out of it, and which link will be shared by the NPTEL team. Otherwise, by the end of session, I will open my YouTube channel from where you can see the videos. Okay, so that's the general background of mine and what we're going to do here. Uh, in this sessions, usually how I look at it, I will take usually mostly hands-on approach here, and whatever technologies have been discussed in the NPTEL course, I will take it as a separate thing, and I will try to go through over it during these 2 hour sessions. So what we'll do is in my first hour we will look at one aspect, 10 minutes break, and then followed by another hour. So till 8 it's going to happen. In other sessions also, the other TS taking different kind of approach. They might be solving certain question directly from the NPTEL, whatever the assignments you are having it, and they may take related to that. I may also take it in future thing, but as far as today's is concerned, last time what we have discussed is the need of for us to uh, appreciate the data analytics and the kind of data we have, and we have a lot of data. So we went through, for first hour kind of thing, we went through a lot of stuffs. I showed them a lot of different kind of website where we get a lot of data, and now our task is to analyze it. So for that we discuss about something called as Google Collaborative, where I'm going to write the code on its online notebook, runtime notebook, like Jupyter. We introduce like how its function works, and then we introduce basics of Pandas. In this session, we'll continue with that Pandas session itself. We are going to go a little bit more deep in the how to use Pandas in the simplest of data, which apparently you can use in your NPTEL course. So that's what has been done last time. I will revise through what we have done in Pandas, and then we will start to it. Okay. So now let me share the screen. It's coming it up. Okay, let's go here. So in the last session, we discussed about the whole interface of typically a Google Collaboratory, and we are going to write most of the code here, and then based on that we discuss that kind of libraries we are going to use this course, what is Pandas, how you can install them. At the same time, we created small data set and we told about what is series, what is data frames, what is label, all the stuff. Now we are going to move a little bit ahead, and then we will see what other things we can do. So what I will do is I will share this Google Collaboratory notebook as a viewer settings. Ask him to add me on WhatsApp group. Omka, I'm not in any of the WhatsApp group, so I don't know. Like, you have to ask someone else, or maybe the NPTEL group if they have formed. We haven't created any WhatsApp group as far as I'm concerned. Yeah, I will make the font a little bit big. I'm just giving a little bit this thing. Okay. Okay, so we talk usually about last time what we talked about how to create a data set. A data set may be as simple as a dictionary, a key value pair, or maybe a table. I will just show you a table that we are going to use today, just like it's a CSV file that is called as comma separated files. So a table can be max to max like this, which it has multiple columns, and each column, sorry, a multiple columns, and each column has its own value, certain kind of values, right? So we are going to focus on this aspect as well. So let's start with what we're going to do is mostly the data set. Whenever you're going to work on any data set using pandas, you have to read the data set. Okay, you have to read it, you have to analyze it, and then you have to make some information out of it. So what the common, there are some common files which we use in a certain format where the data set has been stored. So one is CSV, which is called as comma separated values. This is one format. It's just like a txt that you say, right? Txt or exe file or mp4 file. Those are some file extensions. So these are called file extensions that we are having. Okay, so there's something called as CSV, then there's something called as JSON format. So these are some type in which you may find your dataset values. There's something Excel format, it's called XLS format, right? So multiple format as there. Most common is CSV format, where you put your data in a comma separated values. Even though this is looking like a table for you because it has been shown in a certain, it has been rendered by the Google, but if you actually look at raw file, it will be separated as 60 comma the date, whatever the date will be, comma 110 comma 130, just like that, right? So so what we for the first task, when you analyze the data set, you have to load the data set. So first task is load the data set. So I have some data file already with me, data CSV data 1.csv, which I already have it. I uploaded here through this icon, that files icon, file uploading icon. So from here, since it's a Google Collaboratory, I have to upload it and separately, and after every runtime, it will get deleted. Okay. Yes.
Sir, will this recording be available on YouTube?
Yes, it will be available on YouTube.
Which channel, sir?
I will share with you if possible. Can we talk about that later? It's not that big thing.
Thanks, sir.
I will tell you later all the details from where NPTEL going to give you this YouTube thing, and on all the resources that we are going to have it. Okay.
And sir, where is the material like these files which we are using?
It will be shared by NPTEL. Otherwise, I will share right away. Also, I can share you, just like you can download it. For right now, you can just see what we can do, and if possible, you can create your own Google Collaboratory thing, and then from there you can. Okay. And okay, there are few things I don't know anything, any of WhatsApp group that is related to with this course, and YouTube link. Once I record, I have to upload to YouTube, so then only I can share. So these are things which I can talk about later. Okay. Okay, so we have to first load the data set. So we have to read the CSV file, which usually a common format, which through which Pandas as a library takes it. Okay, so and it's and we should consider why CSV file. Uh, So basically, when your data set is having, right now, whatever data set I am having, it's mostly of 169, 170 lines of rows. Okay, just let me show you. Till it's 170 rows. That's maximum I'm having. But usually the data set that you're going to contain, it will be in GBs of data, and that will be maybe lakhs and crore lines of rows. So you can't analyze each and every one of them. And CSV is a most compact way to store such values. Store the values which might be in a tabular form. Okay, so it helps you to analyze bigger data set very fast in a fast manner. Okay, so how you do it? You have to import pandas as a library and we are giving alias as PD. Okay, I'm starting with this, and then I'm creating a data frame, which usually the terminology which you in Panda is called as df. You can name anything because it's a variable, and I have to call the command read.csv, and then I just have to pass the file name. The file I have right now, it's with me in the Google Colab already, data.csv. Okay, so if I once I run it, and if I just print it df by just printing it off, so I will get uh, the values of I have 169 rows into 4 columns and top 5 rows, and it shows the last 5 rows. Okay, just because it just want to show the compact form. If you want, we can show if you want, we can look at the more bigger the whole data set. Just by you have to write print dot df dot to string. If you do this, so it will show all the values whatever we are having here from 0 to 169. Okay, so to display all the values in the data frame, you have to use to string. Otherwise, if we just write df as it is as a command, it takes as a command and will print the data frame. And when we are saying df, it's basically it's a data frame. It's a kind of data structure which it's a tabular data structure, multi-dimensional data structure which be used by pandas by themselves. Okay, now let me go down. Okay, so there are few things you can do. So for example, I have 169 rows. It doesn't matter. It might be small. But what about if we have hundreds and hundreds, like lakhs and lakhs line of code? You can't see through. The system itself will not allow you because the memory will be very big. So what in that case you can do is there's some functionalities which has been given by pandas to analyze certain rows of from your data set. So first is df.head. So if you just do this, so what it will show the first 5 rows, first 5 top rows. Sorry, first 5 top rows from the data set. If you want maybe 10 rows, 20 rows, just to understand the data set more, like how the data set will look like or what kind of values it has, it will show. You can add 10 rows just like that, and then if you just run it, you can see 0 to 10, first 10 rows. Similarly, if you don't want to see from the top, you want to see from the bottom, like how the data set is from the bottom. So you have just write df.tail. So df.tail, and then it will see from the last 5 rows. It will show last 5 rows, and if whatever you write here, like maybe 10 or 20, it will show the last 20 rows. It will show last 20 rows. Okay, so these are something to get to acquaint with the data, and you have to acquaint with the data whenever you try to do some kind of analysis. You can't justly go and just apply certain function just like that. You have to know what kind of values they are having. So for example, if you just have to analyze it, so we have, if you don't know anything about data and you have to make sense of the data, you just look at what kind of column names you have. You have duration, pulse, max pulse, and calories. So something might be related to maybe related to food intake or the exercises or something like that. Maybe 60, maybe here 60 seconds or 60 minutes, something like that. Pulse may be heart rate, maximum pulse, maximum heart rate you have achieved, calories like that. That's a fun one kind of analysis. Second kind of analysis, you can see that duration pulse and Mach pulse, these are all are integers, and calorie is written in a float value, like that means it has decimal values, right? So you have to analyze certain kind of information. So in a small setting you can analyze, otherwise what you can do is there's a command called df.info, basically info function. So what it will do is it will tell what is df is, basically what kind of class it belongs to, that is a data frame. It will tell the range, that is number of rows, number of columns, that is here it's 4 columns, and then it will tell about the columns name, that is duration, pulse, max pulse, calories. It will also tell the non-null count. Non-null count means the number of rows where the values are there, that means there is no empty values there, because in real time data set you will get some kind of inappropriate data. Your data might not be full. We will discuss the what kind of data you might get, but your data might not be full. Some rows are empty, some values are wrong, right? So it is telling that out of 169 rows, out of all 169 rows, for duration, pulse and max pulse, they all have values, but in calories there are 5 rows where the values are not being present, right? So how to deal with those kind of things, we will see right now in just few minutes, right? And it will also tell the type of the variables that the data is storing. So 3 are integer 64, that is 64 bit, it's called a 64 bit. So there are three columns where the data has been stored as integer, one column which has been stored as a value as float, that we have discussed here right now, the calories row that we have with decimal numbers, and it will tell us about the memory usage. And now just imagine that if we have only 169 rows, you have 5.4 kilobytes of memory usage. If you just give if you cross this into 1 lakh or 10 lakhs, the memory usage might be increased to MBs or GBs. So, and that data might not be able to handle in such cases. So we have to see some other ways to how to handle such cases as well. Okay, so basically df.info will tell about provide uh, a summary about your uh, about basically about your data set. Okay, so that's what it will do. Now what we have to do is now there's something called as, now we have seen here in this case the calorie has 164 164 values, rows where it has been full, and five rows where the value is not been properly has been written, right? So in this case what we have to do is one of the data analytics processes, data cleaning. Okay. uh, Data cleaning. So what it will do in data cleaning is uh, what we are trying to find a means, find a means of bad data in our data set. Okay, so what it essentially tell that let me show you an example for this, that will be better. uh, Okay, so now we have some another data set, a kind of thing, a random data set. Now in this, some bad example would be like, I have calorie but suddenly a value of nan came. Okay, so this is not expected here, because majority of has some other values, integer value or some numeric value, but here I am getting the nan data. Similarly, in this case where the other rows are dates, I am getting nan, like again some nan data. That is one way. Another kind of wrong information you can find it out, like, sorry, um, like here I have dates and it actually written in quotes. Okay, but here you find that this date which is written, it's not in quotes, so it might be written in a different manner. So we have to change it in a certain way where how in a way such that other it should be similar to other data as well. Okay, that might be one of the case. Or maybe here like 450 duration, right? I have other duration maybe 60, 60, 45, 30 kind of thing, but here suddenly I have a data which is 450. So this makes the data a little bit outlier. Outlier means it's not with it's something different from whatever the existing value is supposed to be. So in this case, we have to clean this such kind of instances, because unless until we clean the data, then only we can analyze it properly, because we will have a consistent kind of data. Okay, so we have first is, and this is one of the most crucial part, and it takes lot of time. Okay, it takes a lot of time to clean the data, because you have to understand the data and you have to find multiple instances where your data set might go wrong. Okay, so there are some bad data categories, so let's look at those things we have already seen right now, but let's see more about that. So okay, so first is empty cells. That means I don't have any data in that cells, maybe it's totally empty, or data is in wrong format, that we have seen just now. And we will have wrong data, that is 450 kind of data that we have seen. This another one which is interesting is duplicates. Duplicates is like we have 2 rows or 3 rows or 5 rows which consume the same thing, and these are something we should avoid it, because it is while doing analysis, it analyzing a certain way, maybe you are trying to extract the mean, mode or median of particular data set or some correlation out of that. At that point of time, these duplicate might influence a lot, so we have to remove such instances as well. So what we're going to do now is basically try to see how to remove such kind of empty cells. Okay, so that's our task would be right now. Mostly the whole session will be on this clean data cleaning aspect through pandas. Okay, now let's start with the first thing, that is empty cells. So in empty cells, this is we have to so there are some dealing strategies like how to deal with them. So the first would be directly to remove that row. So wherever you find that there's a empty cell in this case, or for example nan, we will just remove this row directly. We don't have to process it. We don't have to. This is one of the fastest way to do it. But if we have a lot of data which is in this format, that might not be beneficial. But at the same time, we can counter argue that if we have 10 lakhs of lines and if we just remove 1 or 2 rows, it doesn't make any much difference as well. Okay, so one way is remove rows, one is replace empty values with certain values, by default values you might give. Okay, or you replace them using mean, median and mode. Okay, so we will see all these things. So let's start with remove rows. Okay, so how do you do that in pandas? So for this, I have a data.1.csv which I have opened here, and I have more different kind of, because this data set have multiple issues with it. So we are going to try to clean with this, clean that data set. So I already uploaded this. Let me share this also with you. Bad data is, you can say it's not a useful data, or it might be useful data but it's not in a correct format, so we have to make it in a proper format as well. And memory matters a lot, because we are dealing with data where we have maybe in GBs and TBs, terabytes of data, and it's ongoing data. It's mostly most of the companies that they're dealing with, they're having ongoing data. So it's not even 169 rows, they're having everyday GBs and TBs of data. So memory a lot matters a lot. Okay, so let's start with the first aspect of it, that is removing a row. So what I will do is, since I have data1.csv file as my this thing, so I will read that csv data1.csv. I'm just reading that using csv command. And what I have, there are two ways of removing the rows. So what I will do is, I will create a new data frame, and in that I will do a function called drop na. Uh, and just I will do new df.info. Okay, and I will just, for the understanding sake, I will just show what difference might make after using drop na. So we can drop na removes empty rows, or or the rows with empty cells or with value called nan. Okay, so just try, let's read this. Okay, so what we are doing is, in a data frame called df, we read all the data1.csv data. So if you can see here, usually we have five columns with duration, date, pulse, and mac pulse, and we have almost 32 rows in this, and 30 rows, 31 rows in something, based on the how the data set is this. Now we create, what we did is, after using drop.na, we are storing the value in on a new data frame. We are naming as new underscore df. So if you observe here is, using info, we found that all the data set, for all the columns, it has been reduced to 29 rows. That means it has removed almost 3 rows out of that. Okay, so that is one way of looking at it. If we just print out new df dot to string, so you will find almost every single thing where the nan is not present. So for example, in this data set, so here you can see there are 3 nans. So it's considering nan as an empty cell. Okay, since it is an empty cell, it is removing the whole row. So we have 3 cell like that, so it is removing those rows. That is one way of looking at, one way of doing this. Okay, so what is doing, you're creating two data frame in this case. So but if you don't want that scenario as well, like you just want to change the same data frame itself, what you have to do is, you have to do drop na, the function call, and you have to do in place as a parameter, and you have to say true. So what it will do is, it will change the data frame the data frame itself. Now whatever you have seen new df, it has been copied, the whatever the changes has been done from the actual data frame is been copied in this. But now but data frame on whatever has been read is will be like this only, with 32 rows. But now if I put a parameter called in place equal to true, if I do this, then if I put df.info, you can see that the number of rows has been reduced to 29 instead of 32. So this is usually beneficial if you don't want to use much memory of your system. We just want to play with the same data frames. Okay, this is one way of doing this. Okay, another way of instead of, if you don't want to remove any rows, what you can do is, we can replace with a certain value. So replace an empty row or cell with a predefined value. So what you have to do here is df dot fill. I have to again read it because I will get the original data set, and then I just have to write df dot fill array. Fill array is a function, and I just have to see, I have to give a particular value, and I'll just put place equal to true. So let's run this, and if you just put df dot toStrings, you can see this 130 here, maybe another 130 we can find somewhere. Maybe this is the 130 that we are talking about, or any other place also where the 130 is there. This is this case. Okay, but here we can see that what it is doing this, since we are giving specific just one value, wherever these are the pandas is finding the term nan, it is replacing it with 130, which should not be the case. So for example, here the dates, it should be here 130 should not come, right? So what we have to do is we have to specify the columns here. So wherever we want to change the specific columns, there we will try to put the predefined values. So what we can do here is we have to write df. I will write calories because that is one of the column name, and I will just call the function fillNA, and I will just do 130 in place equal to true. In place equal to true means I am changing the its own data frame itself. I'm doing nothing. I'm not creating any new data frame, and just I'll just print it out. And if I do this, okay, so this has been already taken. Let me do one more thing. Okay, so what it has done is wherever they have encountered NaN in calories, they replace that with 130, such that this is 130 instance of 130, and maybe another will be like this. This is 130. Now in this case, they haven't touched anything from the date column because we have specifically told that we want in calories wherever there's an empty cell or nan, we are changing with 130. That's a predefined value that we are giving. Okay, so this is second way of doing this, that is we are replacing the empty value with certain predefined value. With certain predefined values. Okay, now there's a third method which we can use here, is that is replace. Now we don't know that whether the predefined value will be correct or not. So what we will do, we will try to extract, we will try to find certain kind of average from this. So replace the empty cell values using by finding mean, median, and mode. Okay, so what how we can do it here is, let me read it one more time here properly. Okay, so the reason I'm reading CSV again and again is to get to the original value of DF, the original data set. Okay, so now if I have to find, so for example, I know that in calories I have some two nans, two empty cells. So what I can do is I will try to find the mean of that calorie. So to do that, I will just write calories, and I will write and just I will call the function called mean. Okay, mean is basically the typical average, and then once I get the mean, So in the calories section, I will call the function called fillNA. I'll replace that with mean, which we are stored in x, and we are just putting place equal to true. Okay, and then we will put uh, here we just print it out. Print df dot toString. Okay, let's do this. And if you want, we just print the mean also, so that we will know what the value of that. Let's run this. So mean we got is 306.68. So here where we, so in this place, if you can observe the highlighted part, here earlier it was used to be nan, so it is replacing that directly with the average value, that is mean value. Similarly, in row number 28, we are finding the same thing. Okay, so this is one way of doing it. Another, that is through this mean. The other two ways that we can use this, I'll just copy paste here. Instead of mean, I will take median. So what median is we assort the calorie values from small to top, so smallest to largest, and whatever the middle element will be, it will take that as a median. So if we take and run this code, I didn't do much in the code. I just changed the value of call the function instead of mean. I just calling median here. Okay, and whatever the median value will be there, in using fill na function, I am replacing that with that median value. So if we just print it out, so median value here is 291. If you observe, last time mean was 304, now it's 291. So the values will be different, obviously. So here it has been changed, the calorie with empty cells value with 291 in this case in two places. Okay, the last method is mode. So let me copy it again, the code. I'll just find the mode. So mode, it will be like it will calculate the frequency of all the values, and whatever the frequency get the most, it will choose that value and replace that with that value. So in this, 300 is the most highly frequently used value in calories. So it is replacing that with, okay, it's still showing nan. So something is wrong. Okay, let me do one more time. Okay, so it's not working here. Okay, so what I have to do is I have to give, okay, so what is happening is when mode is happening, so it create a list of it will list out the numbers in ascending orders, in a descending order, in terms of the number of values which has been most frequently occurred in calories. So I have to take the first value of the mode. So if I do this, so the most frequently added mode is 300, and then if once I do this, you can see 300 has been occurred in the respective places. Okay, now this has been done only for we are just replacing the empty cells or nan values with different values. Now what we can do is we can remove the data in a wrong format. We can change, if the data is in a wrong format, we can change them as well. We will see right now, but let me see if there any question. Okay, see the mean median mode is how to, okay, so when we say cleaning data, that means we are replacing certain data which is not useful with a proper set of values. Now the proper set of values can be found in multiple ways. Mean median mode is one such ways. Okay, so if I have the data with nan, I don't have any value here. So what I will do, I will take all the values of calories from there. I will try to find mean, mode, median, and then whatever the value I will get, I will replace this nan value with those values. So that's how that's what we say cleaning of data. Cleaning data can be multiple ways. Drop NA will only remove rows that have nan. What about the blank cells? So usually what pandas internally do, it automatically replace that with the nan value. If not, then we have another function where we will find another functions which will find empty cells and you can replace that with NaN values. Okay, so drop an A will you can do in that way as well. How to open files from Google or online? uh, Open files, if you want to do that, if you can see in Google Colab on the left hand side, there's some logo called files. If you click on that files, there's a uploading options will be there. There you upload your files and then you can play with them. Okay. uh, was the use of in place, please explain again. Okay, in place is what happening is, okay, let me show the first code that we have written here. Okay, so when I am doing drop df dot drop na, uh, that okay. So first, let me go sequentially. Your data dot csv, whatever the value of data set, has been stored in the variable called df. Now, from that df, you try to drop empty rows. So whatever, now the function will remove empty rows and it will again store the value in a new variable called new underscore df. Okay, but if you don't want to create a new variable, what you can do is you have to put a parameter called in place. Okay, so when you put in place equal to true, then what it will do is it will not create a separate we don't have to create a separate variable for that. It will store directly in that particular df variable itself. I hope that make thing clear. Okay. Okay, slower the thing. Okay, I will try to do that in next part. Okay, so what we can do here is, here what we can do with the NaN in the date attribute. Here you can't use mostly, you usually can't use the what you say, the mean median mode setting. So either you can remove that row or you can replace it manually. So how to replace that, I will just show you that how to replace this. Okay, so another is, do we have to import pandas, numpy to Jupyter Notebook or Google every time we start with a new file? Also, please, if you could tell the proper way to access, open and close Jupyter Notebook. Okay, Jupyter Notebook is mostly you have to install in your system. So, so you have to follow their documentation of how to use them properly. Here I'm doing online, so in Google Collaboratory, whatever the system is been assigned is done by the Google, and in that mostly all the these pandas and numpy will already be pre-installed. While in Jupyter, if in your system, you have to install such libraries. Okay, and for that you have to use you have to check again on internet like how to install them. Replace part. Okay, so the replace part we have seen in a 3 different ways. So in the, so what we have seen is, let me go above. Okay, go above. Okay, so in this case, if you have to change in data cleaning, we are looking at 4 different aspect here. That is empty cell, data in wrong format, wrong data, and duplicates. First case, you have seen empty cell, and we have to if you have to replace certain values. In this case, we use a function called fill na. Okay, let me show the part of the code we have used fill na. So this is a case of one thing where we use fill na to replace a certain value. So what we say is df, and we are accessing a particular column from the data frame. In this case, the calorie. We know that because it has its own column named calorie. We are accessing that, and we are using fill na as a function. And we are first parameter that we are passing is the value that we with which we want to replace. So in this case, I gave directly 130 as a value, and then in place true, as we discussed earlier, it will store the data in df itself. Okay, so once we use fill na and we provide the value, it will replace the values with nan, the nan one that we have.
So can I speak?
Yeah, sure, please.
If in case I wanted to store that replace in another variable, the fill part which we're just showing right now,
Mm-hmm.
where in place equal to true is there. In
Mm-hmm.
case I wanted to store it in another variable, say maybe f or whatever.
You just
So
remove
could I
this.
remove the
Yeah,
okay.
you just
So
remove that.
okay, so it won't throw an error.
Yeah, it will not throw an error. It's just for memory optimization. Like right now, it doesn't make sense for a small data set. But if you have GBs of data set, then it's not advisable for you to create a separate variable for that.
So and why have you picked calories as the column?
Because the data set that is a dummy data set that we have created, in that we have certain false values. Let me show whether I can, it's there or not. Okay, let me show here. So in this calories, if you can see in E column, okay, in E column, I have two rows where the value has not been provided and it's provided with NaN. That's why I choose calories. So I have to change the values of this calories row where the NaN is there. That's why I specifically use calories.
Okay. So info as a function won't give you this detail if you have
It
any
will give,
empty text.
it will give, but you have to interpret it. So for example, uh, here uh, the data set that we just saw, in this, if you can see, there 32 is the max number of rows that we can see, but in calories we have 30 rows where it's non-null value. Non-null value means it has some values.
Okay.
So you can, from here you can interpret that there are two rows where the value is not present.
Okay. Understood.
Okay. Yeah. Why new df to string converts only single column to string? Okay, the to df string to underscore string is basically, it's just converting your whole data frame into a particular string variable and just printing it out. It's not only one column, it's converting the whole table as a string.
No, but just check the data types of all other columns also. It's showing integer 64 and like this.
Okay, no. The to string is part of just printing it out. You can just look at the d types here by using info function. Am I misinterpreting your question? I didn't understand now.
Uh,
Confused.
Actually, I think that it should convert all the information into strings.
Yes, that's true.
But here we can see integer 64 and you can see float 64, all these
Okay,
columns.
this is the output of info.
New df.
Yeah, new df.info is the output of it. It is giving this output, the highlighted one. I'm highlighting it now.
But new df is itself obtained from converting to strings of that original data frame.
No. So if you see, this is a separate cell and it says separate command. When I do this, it gives a separate different kind of output.
Okay. Yeah, now I got it.
Yeah.
After this, we will check that. Then it will show everything as a string.
Yeah, you can try it out. I haven't tried, but but for that you have to store it in some other
Yeah,
uh,
some variable.
some variable.
Yeah.
Could you share the drive link again? Okay, I will share that now. Um, web files in Jupyter. Can you define what is? Do you mean by web file here?
Any data file. Suppose UNESCO data is there, so I see on the web.
So you have to download in a certain format, maybe CSV, maybe Excel, maybe JSON. It has to be downloadable in a certain
question
format.
is, can I directly take the web values directly in Jupyter?
Directly,
Instead of
mm,
storing in my PC.
no, you
Some
have,
extra packages will be required. URL lib, some
yeah,
sort of.
you have to still, you have to put them in a certain format. The even though whatever the, if you see a data in a web page in a tabular format, for you can't access that table because it's stored somewhere else in in their server. So you have to, there's something called a data scraping. So you have to scrape that data from that website and you have to store that in a particular format, maybe in a table format or maybe in a XML JSON format, just like that. Then you have to access them using Jupyter by giving them a path wherever the file has been stored. Directly you can't
Parsing
do
will be
that.
also required, I think.
Sorry, come again.
Parsing will be also required.
Yeah, data scraping. It's comes.
Yeah, because
Data scraping
we
is
are
it's
accessing an HTML page.
yes. The data scraping is whole another subject that we have to look upon how to scrape the data from a web page or any other sources. So for that, not even parsing, a lot of other things you have to do. How to upload file using URL to a variable. Uh, can you be more descriptive about here? Like, can you give me scenario like how you want to do?
Like if we have the URL of one dataset which is in CMV, CSV format in web, then can we just assign that dataset into a variable using that URLs?
Yes, you can do that. Like if it is accessible, the link is accessible, you can directly store that in df equal to, I think the function name I don't remember exactly. Uh, I think you don't even need to do read. Oh, you may have to do read and provide the link, that whatever the link is happen, and it will access whatever the Jupyter or Google app you have. It will access the file.
Just
So
instead of the name of the file which we
no. You
initially
have to provide the whole link.
okay, we just have to provide the whole link instead of the name of the file.
Yes. Exact form, the exact syntax I have to check through internet, but it can be done for sure.
Thank
Yeah. Yeah, this notebook will be shared by NPTEL. I will also, I will again, if you want, again, I will put this link here. You can access, or you can save the link somewhere. Okay, it's around 6:53. We can take a 10 minutes break for you people. We will come at around 7:05. Okay, and then we will do the remaining three parts. And we time uh, helps. We will try to plot some data as well, like to visualize the data also. Okay, we will do that. So by 7:05, whoever wants to take a break, they can take the break.
Thank you.
Yeah.
So I had a question.
Yeah.
So my question was about lock and iLock. I was
Yeah.
actually trying it in Collaborate, Google
Mm-hmm.
Collaborate.
Mm-hmm.
But what was happening is in the videos, Sir Ramesh, he explained that when you use iLock
Mm-hmm.
and the numbers that you put,
Mm-hmm.
n-1, the row will be shown.
Mm-hmm.
So
Okay.
suppose if it is iLock 4, 5, it
Mm-hmm.
will show you the third and the fourth row.
Okay.
But when I was trying it in Google Colab, if I put 4, 5, it was showing me the fourth and the fifth row. That n-1 logic was not working for me. So I just wanted to confirm that.
Okay, so they might. Okay, I need to check that. Okay, let's try it out if you want. This thing here. Let me try this thing out here. So let's. Okay, so you are saying df.log, and just suppose I'm writing 3 and 4 and just printing it out. Okay, what is the error I am having?
You will have to put another this square bracket.
Square bracket, right? Okay. Okay, so I'm getting 3 or
3
4.
and 4.
Okay, and if I do df dot ilog, same thing if I do. Okay, for me it's showing the same data.
For me also, sir, but in the videos it was explained that if you use lock, you will get n-1 rows.
Okay. Okay, so how the basic distinction between lock and ilock was, like, instead if I don't have 3 and 4 here, if I put A to Z as a labels, there's something called index and labels. So if I put instead of 0 to 1, 0 to 31, I will put A, B, C, D to Z or maybe something like that. at that case lock will work perfectly fine. But ilock, when it comes, it will focus on integer location. It will look at the index as an integer location. That's the only difference I can see. That's why it's ilock. Like I is basically for integer. Okay, so if ABCD is there, if I change this thing, then it will work. It will look at the index as AB at 0, 1, 2, 3, 4, 5. What you are saying is something I need to again have to look at it. Can you tell me the like what is the lecture number for that?
Yeah, just to make a point here. See,
Mhm.
basically in ilog, when you put 3 and 4, it will access the rows with 3 and 4 numbers only.
Yeah.
But ultimately, what it is accessing is the fourth and fifth rows in the data frame.
Yeah, it will start from 0. That's why.
Yeah, so it starts from 0. So if you want to n minus 1 row, like if you want to access the fifth row, you have to mention it as a number 4.
Uh, that's what you're saying is true, and that is there for almost every single thing. Like by
Even
default,
log also works in the same
yeah,
way.
by default it starts at 0, but I'm just telling the basic difference between that.
Yeah, understand.
Yeah.
Just in
Uh,
case if you want to access like fourth or fifth row, you have to give is 3 and 4. That's all.
yeah.
While inputting itself.
iLog gives negative values. iLog support negative values as well. That's true. But Lysandra, right?
Yes, sir.
But still, you still have some doubt with respect to that.
With
I
iloc,
don't
we put
have a doubt.
-1.
It was just that it was even in the assignment, sir. This lock.
Mm-hmm.
It was even an assignment question, assignment 1.
Okay.
If it's in the week 1 curriculum, I don't exactly remember which lecture number, but it is in the week 1 videos.
Okay. iLog, okay, then I have to see it because iLog might give more better functionalities in terms of like it comes something called slicing, like step by steps. All this thing comes into the picture and all.
Yeah, one reason is this because in iloc we have to provide index, and remembering index of all the columns is really difficult.
That's why you give certain labels to
Yeah,
that.
but remembering labels and understanding it through labels is easier. So that is why we mostly use log function.
Okay.
Excuse me, sir.
Yes.
I do have a question related to this matter only.
Mm-hmm.
Sir, I am working on the Jupyter notebook. So while I was using log and using the column names basically, so it was not working. It was showing the key error. So may you just tell me that where is the actual problem?
You just have to, if you just want to access particular columns, so you just have to
Right.
write df, like maybe pulse here, and then you write lock, and then you give 3. Okay. This,
Yes, sir.
wait, pulse is, okay, it has to be, okay, so but still giving error, right?
Yes, sir.
Okay, ideally it should work. Let me see once. Mm, okay, ideally it should work, but why not working? Data frame 1 index, okay. Oh, I have to provide index. Yes.
While using log, it's the first rows and then columns, right? The syntax.
First rows.
First, you need to mention the rows and then columns, right?
I'm no, right? Like we can directly mention the column and then we can specify the rows. Like you can do the other way also. Like I'm just trying to see why it is not happening right now. This one should work.
I think
Okay.
Pawan is telling the right thing. First, we should have the rows and then columns. Otherwise, it will get confused whether to access 3, 4 or 4, 3.
Okay, okay. So, okay, let me see this problem. Distance is there, population is there. So I have to give the index first. Okay. Key. Okay. Mhm. So you are saying here, say I should do first df.log here, and then I have to provide the rows. Is that what you're saying?
The location should contain this, the row index. Yeah, it's 3.
It's
So
3 comma.
also I have accessed all the rows using a colon so that all the rows will get accessed, and then I have to just access the specific columns, naming the column name, like I have created a record of a student report. So using scope and that marks one, I have to just access only the specific columns. So while doing it, it was not giving a proper output. It was
Mm,
showing an error.
okay, okay.
Yes, sir.
Mm,
I think this works. What you put in the chat.
So sorry to interrupt. The lecture number is 2, week 1, lecture 2,
okay, let me. Yeah.
in which LOC and ILOC is mentioned.
Mm-hmm. Just a minute. Okay, this one will not also work. Column number. Uh-huh. Okay, we will look at it. Is it okay, like after this 8 p.m. we look at it? This, okay, let me. Pawan, this is not. I tried this dfpulse.log 3. I think. Um, think. Let me check.
I think maybe the column name issue. It could be.
Now, if I just do column name, I can just directly get it. I can get it. The only thing is
So
how.
just put the column name in the box bracket. I think that should help.
Yeah,
Sorry, yeah.
but
Column names in the brackets we need to. Yeah, exactly.
like this, right?
Yes, yes.
Yeah, that's okay. But what the thing is, the lock, like using lock, if I do this,
I'm just correcting my syntax.
oh, now it's there. Okay, I have to use another square brackets here. Okay, so if I put 3 and 4,
First, we are selecting the column and then the location.
yeah, earlier also we did that. The
Yes,
only
yes.
thing is the syntax of 3 and 4 was not proper.
Yes, yes.
Hmm.
I'm
Okay.
missing the syntax.
It's mostly a missing of syntax. Okay. Yeah. Okay. So yeah. Any other question before we start? Okay. So we'll start with the next thing. Basically, Narayana, please look at the drive link earlier. You can't access the earlier drive links. I can't pin it here also. Okay. Let me give you one more time and then we'll start. This is the data one. I hope I given the correct one. No, I don't think so. When to use second and third parenthesis? The square brackets you might be saying here. Okay, so it is mostly like it is consider you have to see the dimensionality of the table basically. So if you just put if I just put 3, ideally it should work, but it is somehow for some reason it's working. It is just showing the row, but if I need more values, then it has to put in a certain frame, like it will create its own list, particular list, and from there it will give. So the more, if it has more dimensionalities, if considering it's a table, you just need max to max two square brackets. But in scenarios, I haven't used more than 2 square brackets here. So I can't tell you right now that how many square brackets I have, but max to max you need 2 to access a particular row and column value.
Excuse me, sir.
Yes.
Sir, if I need the rows, all the rows, and 2 specific columns, so what would be the index? What would be the syntax basically?
2 rows and specific columns.
Yeah, all rows and specific columns.
Specific columns. Okay.
Lock.
No, I just let me try this. This will work.
Will be a colon only for all the values.
Yes.
Okay, and then the column name, right?
Yeah. So basically,
Yeah.
it is like df dot I log or ilog. First we
Okay.
use colon, which takes care of the entire rows. Then mention all the columns you need in the brackets, square brackets. Then
Actually, I did the same what you're telling, but it's showing error in the Jupyter notebook. First, I'll try it again, and then if I'll have an error, then I'll just.
Okay, I have to check that also. Syntax wise, I'm very poor
Yes,
in
sir.
remembering syntax, but this is somehow we have to see. If it's not working, okay, we will see. I will, like, once this session is over, we can sit and we can see that. Is that fine?
Sure, sir. Yes, sir.
Okay. So the next kind of data that we might face in a typical data set is data set in wrong format. Okay, so what we can do is we can, if you find such kind of instances in a data set, you can remove the rows as it is. That is one way of doing this, or you can convert all cells in the same format. Okay, so we'll focus on the second aspect, that is converting all cells in same format. So according to this data, so it is not showing, but it's actually written in quotes. So if we just want to put everything in quotes kind of thing, like this, the highlight one, 12 December 26, 26 December 2020, at that time what we have to do is we have to select a particular column name, and then we have to write, since it is a time, date and time, we can use a function called date time to underscore date time, and then again we have to write df date. I think, yeah, that will be suffice, and print df dot toString.
So we couldn't use in place equal to true here.
Sorry. You can I can put in place equal to true as well. Just a minute, some problem with the, if I just put, oh sorry, I have to put this date time, but let me see whether it has syntax is invalid. Okay, Okay, let me do this again. TF, I have to put date and I will put PD to date time. This should work. Date time is correct, and then I have to pass the particular row date, and then I have to do this. But why this? Key error is date. Okay, I
I
just
think
give.
we have to import package for date time also. We have not imported.
But Pandas has its own function named PF date time. To underscore date time in Pandas. It has its own function name. We don't have to import anything. Let me check what are the values it can have. Data frame is there. To date time argument, I have given argument. That will come. Yeah, this should work. Any other example that I can see? Data frame, PD series, date time S I have. Okay. This is correct. So why this is not falling? DF.
So I think you have not used the circular bracket in the syntax of date time.
Okay, let me check it once.
Yes, sir. I think you have used square brackets date time as a function, right?
Sorry. My bad. Still the problem is okay, the error is still showing the TF date. Hell, date is here. It's date is a parameter is there, so ed date to date time. I've given the argument. Also, okay. This is the df date. Okay, it's if it's not reading. Okay, just a minute. I'm just trying to debug what's the problem here is. If I do this, it's working. Date is the problem. Why? Duration. Okay.
I think the problem is in the column name. I think it's column name stored as data
Duration.
base something.
For
Check the column names.
It's date only, right?
Yeah, I think the column names are not properly stored here. Different syntax. Date space double one or two spaces is coming. When you just put it df dot space.
Okay, so some problem with the data itself. Okay.
Yeah, the format itself.
Okay. So this kind of thing also you can arise where even though it's looking perfectly fine, but
Just
okay.
type df dot column so that we'll get to know how these things
df dot column. What is that function name?
Columns.
Call, right? Call or
Yeah.
column?
Oh no, COLUMNS, columns. No, parenthesis not required. Yeah, see here.
Okay.
But still the code is not, even after taking these as a column.
Yeah, it should ideally it should remove that.
Space after T also.
Yeah, I think duration also have very
Yeah.
good as space. Okay. I need to check that why it happened. I need to read about that.
Strip function we can use, I think.
Hmm?
Strip function before these
Strip.
names.
But in a data frame, how to use the strip function, I have to check. I have no idea. Okay. Let's see what is. Okay, so let me see this. Now, earlier this 26 December 2020, when earlier was written in different format. So once what we did is we used a toDateTime function directly here, and I made some mistakes in creating a data set because of some spaces there between the column. So once we resolve that, we can find almost it has been created in a proper format, except the NaN thing, where it is giving up some NAT value rather than that. So since it can't change its value because we haven't provided any new value, we're just changing the format. You can just drop. You can just directly drop that row. So if there's another, so you just have to use drop NA again, and here we have subset called date, and just put in place equal to true. Okay, I have to give space. Okay, so if I do df date, it will remove that NAT value as well. So we have remaining 31 rows with respect to that.
Just a quick question. Why are you subset? What is the significance of this subset?
Subset is basically just to show that you just you can directly use drop NA, it will remove the row. But if you just want to if you just want to see that you want to remove particular column from column that data, then you can do that. So for example, if I just if I instead of removing, just keep the subset as it is and just print the whole df print or the whole data frame. Let's see whether it remove that or not. It's one other way of writing the code. Here if you can see, it will still remove that particular row from the date. So it's just another way of subset, like if to specify that, just for you to get to know that. Otherwise you can just use df.drop_na. That will work fine.
So it will remove the whole row, right? Not just the set.
Obviously you have
up, no?
Because you have to remove the whole row, because the other values will get affected. So that means one column, that is date, will have 31 values and rest of the columns will have 32 values. So that is not desirable. So usually remove the whole row. Okay. Now another thing that we can do is discovering duplicates. We have to discover duplicates and just we have to drop them because duplicates is just not much of value of us. So in this data set we have two duplicate row, that is this, row number 13 and 14, so it has exactly everything as same value. In real scenario they might be very same values, but in our context if you just want to remove duplicates, that's your business requirement, just like that. So in this case you have to use the function called drop duplicates. So just let me read that. Take the original data set as a data frame and just have to write df dot drop duplicates, and I just write in place equal to true. And if we just want to see, earlier we have 32 rows. If I just show you here, we will have 31 rows max. The 29 rows are just like the non-none values that we have taken directly from there. Okay, and another thing that we can do is, if we have to remove a wrong data, like the data just like we have seen the nan in date or any other things, we can replace that value. So to replace that we have to use log kind of function. So to if we have a wrong, if I have a incorrect data, mostly either you replace it or you just remove it, replace or remove. So what you have to do is df.log, and suppose in this in specific case you can identify the particular location. So for example, on this 1 2 3 0 1 2 3 4 5 6 7 7, I guess it's 1 2 3 4 7, yeah. So at here on duration, okay, just what happened, we have a value of 450. So if you just want to remove that, maybe if 0 has been inculcated just like that, we have to make it 45. We just had to write, we have to give the row number, the column number as we have discussed earlier, the the column name, and just we have to give the value as it is. And if we just print it out, print df dot head, because it's in top 10, I'll just top 10. Okay, okay, I have to store it somewhere, right? New df dot head. So why it's not showing? Ideally it should work. Print df dot toString. It hasn't replaced. Why is that? I have given the value, log is given 7 and duration. Okay, just a minute, I just need to check this. Df columns, what is that function name? Duration, I have to check this. Okay, so because of writing in the column name in a very bad fashion, all these errors are coming. So if I just do df dot head 10, it should change. So at the 7th value, earlier it was 450, now it has been changed to 45. So basically you have to use the log function or ilog function, and from there you can do. Another way, a template that you can use, so for example this is 32 values, right? So you can't check each and every rows just like that. So at that point of time you can create a normal loop function. So you can just write df.index. So it will check the index and it will check df.log and whatever the row number will be, and then I have to give the duration function, and I have to check that if it any duration is something like, if we are keeping anything above 120 in terms of minutes, something like that, if that system occurs, we just have to write df dot maybe drop or maybe log change, some change we can do. Drop this and in place true. So these are kind of template that you can use if the number of rows is very high. So what you do is, using df index, you will identify the number of rows. From each row, you will look at particular for each row, you will, for a particular column, you look for a value, and if that value is greater than 120, for example, you will either drop it, or you can use the log function to assign certain values. So there are two ways of looking at it. Okay, so that's how you can replace the data here as well. Either replace, or in this case we are just removing the row. Okay, so this is the
Can you write the syntax for replacing?
yeah,
We have to use lambda function for it.
Either lambda function is another way, like you might create another function, something like that, or here you just assign certain values, whatever the value.
I have posted the code. We have to strip for each string name.
But yeah, okay, just let me check the code. Yeah, lambda function you can apply, like it depends on, again, oh, you're giving the lambda function for the column stripping. Okay, okay, we can do that later. But right now, what we are telling that is, irrespective of whatever the column name is, we have to change that value. So a kind of template you can use here, where you try, from each row you identify the value, and if that value is exceeding a certain threshold, you can just assign a certain predefined values, kind of like that.
Just one interesting thing. So we are now put a function greater than 120, and we are giving a value of 130. Will this loop iterates?
Yeah, it is iterating. I just give 130 as just random thing, but yeah, it will iterate.
Observation.
So yeah, because of index, it is, you are actually traversing each and every row.
Yeah, that's right.
So at every row, you're looking at particular column only. You're not looking at each and every column. You're just looking at the column name duration. So yeah, you can do that. Okay, so till now, just to give a highlight of what we have discussed until now is, as a summary, we are trying to do some kind of data cleaning, where we will have a kind of, we have seen multiple cases where either the cell will be empty, or data will be in wrong format, or a data will be there which is exceeding a certain threshold which we don't need it. It may come as an outlier, so how to replace them, or duplicated row. Or in my case, what I have done is, while creating the data set, I haven't taken care of the column names, so it has lot of spaces in between. So because of that, I'm getting a lot of errors, right? So these are kind of errors that we can find generally in a normal typical data set while creating, and that's why we have to take lot time to analyze it, and you have to fix them, right? So we have seen mostly 2 or 3 methods here, where if certain bad data comes, either you directly remove that row, or you replace that with certain value. If you want to replace with certain value, you either use mean, median, mode, or any other different kind of statistical inference. So you can use those kind of things. Okay, so this is something we can do right now in a normal data set that we are having. Now there's another function that we can use. Let's suppose that now all your data is correct, everything is absolutely fine, everything you have done. So now you want to know that is there some correlation between them. Okay, so you have to find a particular correlation. So like when you have a whole table here, and you want to make certain sense out of it, you want to know that which data, like which column is correlated to which column more. So I may say that the more the duration might be, I might have more higher calories, maybe like this, or maybe the pulse, if I have higher pulse, maybe it related to higher or less calories. Some kind of correlation we need to find it out, and we have to find out to make sense of more data. So how to do that? So in this case, we use correlation function. So here what I will do is, okay, so I just need to let me see with this without. So I will just again read the data1.csv again, because it's not because we have changed its values lot of time. And if I just do df dot, we just have to pass this correlation value. So it will give a table. Okay, now if you have to observe what it is, then let me beautify it a little bit more. Okay, and more zoom. So correlation means when you, so what it will do is it will try to apply some statistical inference, and what exactly those functions are, we can check it through a website. We can go right now, but what it will do is it will take duration as a column, again as a duration or pulse or max pulse as a column. It will compare their numbers and it will see that how much correlated they are. It try to see certain patterns. For example, of like if duration is increasing, does it mean pulse is also increasing? Is it directly proportional, indirectly proportional? So those kind of values it will try to identify. Okay, so for if you look at it, wherever you find 111, that is in a diagonally space, it is correlated with its own value. So we have to ignore those things. But what we have to see is we are seeing that if a duration is given and with certain values of pulse, it is giving very less correlation value. So when your correlation values come, the values will be between -1 to 1. Okay, so 1 means highly correlated. Maybe you can see that 1 refers to directly proportional. -1 will be like indirectly proportional. Indirectly proportional means like if my duration is being increasing, my pulse is decreasing. Pulse is not increasing. That's in like the value, the cause and effect is reversed, right? Directly proportional will be like if my duration is increasing, my calories are also increasing in such way. Okay, and any value which is near to 0, that means they are very less correlated. So if you can see here, the highly correlated values will be calories and pulse. Okay, so that is 0.51. So that means whenever there's an increase, the pulse is increasing in terms of numbers, calories is also increasing. Okay, and if you want to reduce, look at the less number, it is like pulse and duration. That means it is not correlated. If it's, since it's very nearer to 0, it is not much correlated. We can't find any pattern. Let me show you for other data set also that I am having. That's like pt.read csv. It has much more better correlations. Data.csv, and I am just doing df.call. Okay, so if you can observe here, duration equal to calories. This is a different data set. Similar, I just change it little bit values here and there, taken from internet. So here the situation will be totally different. For duration, if it is increasing, calorie is also increasing. Okay, so here pulse, which is -0.015, it is nearer to 0. With duration, it is less correlated because near to 0. Same for max pulse as well. So this data and data1 CSV are two different data set with same names but different values, where we have interchange and make it different. But we can see the correlation with respect to data has been changed drastically with different things, and that is something we can identify. Okay, now we have seen through numbers, but we can see through plotting as well. Okay,
So
yeah.
if we evaluate this correlation and we don't clean the data, suppose it has NANs and all these things.
Yes, so right now I have done this thing. When I take data1 CSV, that we like last 30 minutes we are using on data1 CSV dataset itself. Here I haven't removed anything, like I haven't removed NaN or something. So if I again clean this value might change for sure.
Thank you.
Okay, now this is all numbers, but we can do certain kind of plotting as well. Now plotting will be done using a library called matplotlib. So we just have to do import matplotlib.pyplot as plt. Plt is the alias that we are having. Now if I just have to, I just have to represent data as in a graph. I just need to do is, I just read it first. I will just do data.csv and I will
matplotlib string is incorrect.
yeah, I just need to change that I df plot, and then I just have to show plt.show. If I do this, data has not read csv. What happened? Is this, oh sorry, okay, so it just showed me a certain values. So I just put data set directly on the graph. So it is showing me its values ranging from different to different ranges. So 0 to 175 in x-axis, 0 to 11750. That is mostly for calories, but for most of them it is within 500.
Excuse me, sir.
Yeah.
Yeah, we are using the matplotlib of data set 1 or data set data.
It's sorry, come again.
That data or data 1 sir, file.
Mm-hmm.
We are using data. Now we are plotting of matplotlib of data or data 1 sir.
So it's data right now. We are putting right data read CSV data.csv.
Okay, sir.
Okay, so it is just directly putting that in a plot, in a 2D plot, all the values. But if you want a particular kind of thing, so for example, we are saying that in this data.csv we have found high correlation between duration and calories. So what we can do is we can write in a certain way where we say df.plot. We have to define the kind of chart we want. So there's a kind a parameter, and we have to give scatter. There will be a lot of kind of chart that you can use using matplotlib that you can explore in this, what you say, in their website. And then let's see calories. Okay, if I do this and plt.show, if I do, is not a valid. Oh sorry, scatter is
duration column.
No, the scatter s should be small. No, this data set is different. This is properly curated, I guess. Okay, so how you find that this is it's kind of correlated? And usually when we create, if you have remember that its linear graph should come. So if you create a line from 0 at 45 degree, you can find that x and equal to y. This is kind of correlated, right? So from this data, if you can see that diagonally, if you straight one line at 45 degree, x and y, like as the x is increasing, y is also increasing. It's showing a proper pattern. That's why it is showing correlated. Another correlation that we can see here is less correlation is duration and max pulse or pulse. Let's see that. So I just need to copy this and let me change it to pulse. If I do this, so here if you in this you can't make out a particular correlation. That means even though duration has been increasing, there's no common pattern that pulse is also increasing. Within less duration also pulse has been increasing, so there's no proper correlation. So you can see using pandas this kind of thing as well, where the correlation we can see as the one variable increasing, whether the other variable is increasing or not, or is there any proper relation is there or not. In this case duration pulse, where we can't find any correlation or very less correlation where duration is increasing, the pulse is increasing, or vice versa. So using plots also you can analyze certain data, which and matplotlib and pandas provide a lot of functionalities for that. A small thing that we can, if we just want to check a particular column also, here we are putting two columns here. If you just want to know one particular column, you can just do df dot duration and then plot, and just you put the kind attribute as histogram, which is termed as hist, and if you just do plt dot show, and here you can get some data uh, of the duration. So why it is this kind of plots are useful? These plots are useful for you rather than looking at the data directly. It's better to look at through graphs. So I don't need to know that I don't need to go and open data set and see that what kind of values it has, while I can directly see that most of the duration values that I have in the data set is between 50 to 60 or between 50 to 100, something like that, and I have high number of frequency of here. Okay, so this kind of graphs will help us to analyze and understand that there's a much more better ways.
Can we
Okay.
use describe function also? It will directly give all the statistical parameters, minimum, maximum, mean, median.
Yeah, you can use that as, like, we have lots of functions to use. These are, I'm showing just commonly used and different kind of functions that you can use that, like info, describe. You can use multiple just to get a gist of a particular column, a particular data set, or multiple columns, like that. So a lot of functions are there. For that you have to we have lot of here functionalities in pandas libraries. Okay, so you can go and spend time in this also to I will just post this links, and it has good set of tutorials as well over the period of time that you can look at it, because a lot of functions are there. Okay.
Excuse me,
Yes.
sir, please share today's video and last videos also.
NPTEL will share that with you for sure, and I have to upload this YouTube in the YouTube. I will share that for sure. If you want,
So
give
any
me
PDF file of this videos?
PDF file. Like, see, I have given you this Google Collab link. So if you want, you can just make a copy in your own self. You can make a copy here, or save a copy in Drive, or save a copy in GitHub, something like that. You can do, and you can save it. Otherwise, this will be also be going to be provided by NPTEL for sure.
Okay, sir.
Okay. Uh,
Okay, one question more, sir. If I will extract the Google News data, and I found that the I specified that the date means I want the last 1 week of data of Google
mhm,
in a news.
mhm,
So I want to extract the one column of that data and apply some machine learning algorithm on that.
mhm.
So what can I do? Actually, one way to solve this problem is to create a database table. So how can we create that?
So first of all, how you're whatever you extracted from Google News or Google data, I need to know that from where you have stored it, in which format you have stored it, whether in a JSON format, table format, or any other format. First,
I do not want to store data in any format. I apply any machine learning algorithm on that data and will show the result.
but machine learning require data in a particular array kind of format or table kind of format. Apart from that,
Yeah.
it can't take any other thing. So even though extracting certain data, the storing that data in a particular format is very much crucial. Otherwise, your machine learning model will not able to understand what data kind of data you are giving to that
So
to him.
from that we can create a SQL table.
You can create SQL table or simple CSV files as well. You have to convert that
Yes.
in a particular format. like mostly people prefer, like here whatever we have seen today is mostly for CSV format, which is being stored as a data frame. After CSV also the work is not done. You have to put that in a array format or maybe a data fit format, like how Pandas is looking. That that DF you have to provide as an input to the machine learning model, like whatever the kind of machine learning model that we are having. So okay, to do that, it's better you follow certain tutorials there, how they're storing the data while extracting. They have lot of there are a lot of tutorials out there which tells you how to extract the data and store in a certain format, and then you provide do classification. You provide classification model or regression models on top of it.
If I want the data I can use of one column data, then I will append that data and create a one table of that. So that's why I can from where we can apply machine learning algorithm and then the result will come. So how can we store that data in a one column in a one database? So I cannot find this solution.
Okay,
She's asking about slicing.
slicing, not each
So
if
indexing lock operation and ilock, she can do it.
okay. I'm assuming you have data in this kind of format.
Yeah.
Okay, if that is the case, suppose assuming that you have the data in this kind of tabular format, what you just have to do through Pandas is you have to first read that, okay, read that, and then you just have to, if you just do df, like whatever the in this case duration, okay, if I just press it, I will get list of all the 168 rows whatever I'm having. I will put that in a new variable. I may store that in a new variable, and then I can use that new variable to do whatever the next kind of processing, next step of processing I have to do. See, before even giving to machine learning model also, you have to put them in a certain kind of array kind of format. Machine can understand only numbers, and they have to, even you have a natural language, it will be converted into numbers only at some point of time. And if you actually look at that numbers also, it is stored in a single row kind of thing. It's we call as array, and that thing will be taken as an input by the any machine learning or deep learning models. But carry on.
Sir, actually, I missed last session, so I want the video of that session.
Okay. Okay, just wait for a minute. Let me. I will give you the YouTube channel link. Okay, where I will be uploading the videos. Either ways, you can wait till till the time NPTEL provides you the link. Otherwise, just a minute for that.
So I had a question. I don't know if it relates to the course directly or indirectly, but what is the major difference between using Power BI for data analysis and using Python for data analysis?
It is like, have you used Linux or Windows as a system?
I've used Windows.
Okay, so the difference is like Power BI is like a Windows, it's all GUIs, and Linux is like more hands-on, like you have to type a lot. The developer prefer more Linux kind of thing. Here you will have a lot of functionalities, you can tweak a lot, you have more power like of this. So Power BI is most like a GUI tool where you have to use already available what you say already available functionalities there. You have just to click on that and you will get the result. But in Python, you have to code it out. You will know internals of it. In Power BI, you might not know what is actually happening in the background. That's a difference, major difference.
So Python is like a strong suit, you would say, over using Power BI for data analytics.
Over the period of time, yes. Like if you want to go deep, like you should, if you want to play with them and all that. That
So do we also have to, I mean, in Power BI, do we have to code to get the visualization, or it's
It has
drag and drop?
lot of other functionalities, but it is more like a Windows. Like for example, if I have to show you, just let me. I'm using Mac, but still can show you one certain thing. Okay, this is a terminal that we are having. Okay, and if I don't need to, I don't like people who use Linux kind of things and all, they use terminal a lot. So if I put ls as a command, I can see whatever the files I have, and I have to type it out to change to a certain file. So if I have to do downloads, I have to go like that. I have to write commands like that. Okay, but I know that in the background how it is changing. Otherwise, in Windows, I just have to click, double click, right? In Mac also, I double click. Ubuntu also, I can do a double click. But this is giving me more a raw feeling. Similarly, when you're doing a kind of Python kind of thing, or R, R is another language which is mostly used for data analysis by data scientists. There you have to write a lot, code a lot, but you will know the logic from beforehand because you are coding. Okay, so you know the back end process a lot of things. So that's a difference. It's basically a difference between GUI, the user interfaces.
In MATLAB, we can do all this.
Yeah,
GUI based.
MATLAB is another awesome tool where you can do lot of things by writing commands and all those stuff. So, for example, I haven't opened it, but suppose if this B column is there, I am looking at as an Excel sheet. Suppose, okay, I have to hide it, so I will click on something to hide, and I will get some hide option. Just assume like this. But if I have to, but I'm using a normal command line kind of thing, I might have to write certain commands to hide this column. Okay, so that's a difference. It's more like the output will be same. It's just that you have a GUI who doesn't have much background knowledge. They can use directly GUI. They don't need to know how actually it's happening in the background. Or otherwise, you can use command line tool where you know the process because you're creating the process. That's a major difference. Okay, let me, yeah, found the link. Okay, so here in this YouTube channel, I will be uploading the video after this session is over. Okay. Okay, so any other question with respect to this? So today what we have discussed is data cleaning process and some how to plot the data in this, how to plot data using pandas. In next sessions, we will be going towards little bit of the little bit in line with the course where we're discussing probability distribution. Maybe we'll solve more questions with respect to assignments, data sampling, and all that. And I will see that whether I can relate this with pandas library, whether I can show this probability distribution or a different kind of distribution using pandas or not. Okay, so I will be doing that mostly in the next session.
So also, can you confirm about lock and iLog?
Yes, I will. I will look at this thing. Or if you want, we can stay a little bit late till everyone leaves, and then we can discuss.
Yeah, sure, that's fine.
Yeah. Okay. So in this case, I will stop the recording, and the session is over from my side. So if you have any other thing, please let me know.